Bismillahirrahmanirrahim. In this lecture, we are going to speak about the exponential functions. In which that we are going to define the exponential function, and we will evaluate some exponential functions, and then we will speak about the sketch or how to graph an exponential function. Starting with the definition, the exponential function with base b is defined by f of x equal to b to power x, with b must be greater than 0 and b not equal to 1, and x is any real number. It can be any real number. So for this function, we have f of x equal to b to power x. B, we call it the base of the function, and x called the exponent or power. So we say f of x equal to b to power x. Now for the conditions, b greater than 0 or b not equal to 1. Why do we need these conditions for the exponential function? Let's take some examples about the exponent. Let's evaluate. Number 1, 2 to power 3 is equal to 2 times 2 times 2, which is equal to 8. But the power is a repeated multiplication of the base. Number 2, minus 4 to power 2 is equal to minus 4 times 4, which is equal to minus 16. We have to be careful about the negative sign if we don't have any brackets including the negative. So we'll keep it just minus 4 times 4, which is equal to minus 16. Number 3, if I have minus 4 all to power 2, this is equal to minus 4 multiplied by minus 4, which is equal to plus 16. Now, since we said that x can be any real number, so I can choose minus 4 to power 1/2. But 1/2 means square root of minus 4. The square root of minus 4 is complex. This is 2i. This is complex number or imaginary number. And because of this one, we exclude the negative bases. I don't use negative bases for the exponential function. We are talking about the real function. It means that the output or the value of the function must be a real number, not complex. Because of this condition or of these cases, we excluding the negative bases. And that's why we have to have the base b is greater than 0. Base of the exponential function cannot be negative number. Now for the exponential function, start with the graphing some exponential function. How to sketch exponential function. Graph the function y equal to 2 to power x, or f of x equal to 2 to power x. I want to graph this exponential function. And the graph of the Any function usually takes some points. I have x and I have y. I will choose 5 points. I can choose any value for x. If x is the power, we say the x is the independent variable. It means I can choose any value for x regarding or without caring about the y at the end of the step. I can choose any value for x, but y will depend on the values of x. So we call y the dependent variable. Usually I'm going to choose negative and positive numbers, -1, or let's say -2, -1, 0, 1, and 2. This will be 5 points, will be enough to graph the exponential function. Now, second step, I'm going to evaluate. If x equal to -2, I have y equal to 2 to power -2. Replace x by -2. This is 1 over 2 to power 2. Negative power means write it upside down. So it is equal to 1 over 4. So y equal to 1 over 4. If x equal to -2, y will be 1 over 4. Now if x equal to 1 -1, the second point, y equal to 2 to power -1, it is 1 over 2 to power 1. That is 1/2. Now third point, if x equal to, this is x equal to -1. Now if x equal to 0, y will be 2 to power 0. And any real number with 2 power 0 will give me 1. Third point, if x equal to 1, then y is equal to 2 to power 1, which is equal to 2. So this is 2. And last point, if x equal to 2, I will have 2 to power 2, which is equal to 4. So these are the 5 points for this function y equal to 2 to power x. Now I can graph this function. Now to graph this one, this is the y-axis and x-axis. First point was -1, was -2 and 1/4. Second point, -1 and 1/2. Third point is 0 and 1. The next one is 0, -2, -1, 1 and 2. 1 and 2, 2 and 4. See that the graph of this function take this shape. Make it more nice. So this is the graph of the exponential function f of x equal to 2 to power x or y equal to 2 to power x. We'll notice one thing or a few things here. F of x equal to 2 to power x. First remark, b, the base is equal to 2, and the 2 is greater than 1. It means the function is increasing. Increasing means it's going up. Direction of the graph is from left to right is increasing. it becomes larger and larger because the base is equal to 2 and x is with positive sign, I mean just plus x. If we have minus x, I have to write it upside down. So b is equal to 2 is greater than 1, so the function is increasing. Second point, I have this function f of x is it 2 to the power x plus, there is nothing there. It means 0. This 0 means the graph of the function will not intersect with the x-axis. This one. It will approach the x-axis, but it will never intersect with the x-axis. So we can say that number 2, we call this the horizontal asymptote. It means it is the line that approaching the figure or the graph of the function, but will not intersect with that one. So we say that horizontal asymptote. Horizontal asymptote is given by the equation y equal to 0. For this function, because it is 2 to the power x plus nothing, so y equal to 0 equals the horizontal asymptote, which means that the graph will not intersect with this line. Y equal to 0, this is the x-axis. This is the equation of x-axis. It means the graph will not intersect with the x-axis, the graph of this function. If I have 2x plus 1 or minus 1, then plus 1 or minus 1 will be my horizontal asymptote. Third point, when x equal to 0, for this part, this point, 0, which is this point. Because this is the x-intercept, I'm sorry, y-intercept. Y-intercept. So the y-intercept is at y equal to 1. Or we can say the point 0 and 1. It will be the y-intercept for the graph. So I have 3 main features for the graph. It is increasing because the base is greater than 1. I have horizontal asymptote, which is at y equal to 0, what is written there. If it is equal to 1, then I will say y equal to 1. If it is minus 1, then it is y equal to minus 1. This is the horizontal asymptote. It means the graph of the exponential function will never intersect with this line. Third one, it is the y-intercept, and that's when x equal to 0. Just replace x by 0. The value of the exponential function will be the y-intercept.